So I wanted to show you a little bit of how to do question or slide number 5 on our Desmos activity. And it's asking about what would be a good or a just right number if you had 10 predator within your pond. So we have to go through each of these scenarios and determine what they mean. Okay, so we're talking about a ratio, but how we understand it a little better is as a fraction. It's basically comparing the two numbers. So the ratio would be written where it would have the two dots in between them, or you can write it as a fraction with a line down the middle. So let's go ahead and show how that works. So the predator-prey in pond A, they are saying that there's too many predators. And in this one, they are saying there's too many prey. And they're saying this one is just right. So if we think about Goldilocks and the three bears, this one has too many predators, this one has too many prey, but this one is just right. And it's how it balances together. So if we were to reduce these, okay, so the ratio for the first one is a 12 to 24. Oops, sorry, a little sloppy. The second one is a 12 to 48. And the last one is a 12 to 36. And what it's saying is that for every 12 predators, they're going to get 24 prey. As a fraction, that's 12 out of 24. And if we were to reduce this fraction, maybe make it as small as we possibly can, we would try to find something that we can divide both the top and the bottom by. And you can always start small with like a 2/2. But I know that 12 goes into both the top and the bottom. 12 times 1 gives me 12. 12 times 2 gives me 24. So this is the reduced fraction for this. For the 12 over 48, I know again that 12 goes into the top and the bottom. And what I'm doing is I'm dividing. Okay, so 12 divided by 12, or I can think backwards and think to myself, okay, well, what times 12 is going to give me 12? Well, that's 1. 1 times 12 is 12. And then 4 times 12 is 48. Division and multiplication work backwards from each other. So here we have the fraction 1/4. And then finally, our 12 over 36. I'm going to reduce that using the giant one of 12 over 12 again. And that's going to give me a 1/3. So these are my reduced ratios, my reduced fraction. And why is that helpful? Okay, so what that means is the first one is 1/2. That means 1 to 2. So we change this ratio to 1 to 2, meaning for every one predator, so for every one predator fish, he's going to get to eat 2 prey fish. 12 to 24 is equivalent to 1 to 2. Okay, they're equivalent ratios, just like we do equivalent fractions. Okay, so for every one predator, there's 2 fish. Well, they say that means there's too many predators. That's not going to work because predators need more than 2 fish. Okay, so let's look at the one where there's too much prey. So it's a 1 to 4. We reduce that. They're equivalent, equal. 12 48ths was equivalent to 1/4. Okay, that means for every one predator, they get 4 prey. So if we think of maybe like a 1-year-old child, if we give them 4 chicken nuggets, they may not be able to eat all 4. That could be too much for their bellies. So this could be the situation where one toddler can't eat prey or can't eat that chicken nugget, which is their prey, their food. So there's going to be stuff left over. We're going to run into that scenario where the water got dirty and disgusting because there was too much prey left over. The predators couldn't keep up. Okay. And then the final scenario is a 1 to 3, meaning for every one predator, they're going to have 3 prey. And they say this is just right. That means this is going to keep the ponds clean. There's not going to be too many predators. There's not going to be too many prey. Everything's going to work out just right. So we're reducing that. So now we know it's a 1 to 3. Well, they give us a 4 to 12 scenario as well. So they're saying this is also just right, which means it better reduce down to also a 1 to 3. So what does that look like? I'm going to come up to the top. 4 to 12. And I'm going to reduce that with my giant 1. And what number goes into 4 into 12? Well, actually, I know 4 does. And 4, or I can think, what times 4 is 4? Well, 1 times 4 is 4. And what times 4 is 12? Well, that's 3. 1 to 3. Is that the same ratio that we had down here? Absolutely. So that means we are going to look for something that goes with 10 that gives us a 1 to 3 ratio. Because we're figuring it out. I'm going to give us a little bit of room right here. Give us a little room so that we can figure out 10 predator, which was our top number, over what is going to give us that 1 to 3 ratio as well. Meaning we're going to have to use our giant 1, and I'm going to write sloppy, you're welcome. And we're going to have to figure out what's going to be our giant 1. So up here, you see how I had to divide, which means I'd be doing 10 divided by something and bottom number divided by that something in there. Well, let's go backwards. Let's multiply. And think 1 times what is 10? 1 times 10. And we know our giant 1 has to have the same numerator and denominator, so that also has to be 10. So now we just have to solve 3 times 10 equals, and we're going to get our 30, which means 10 over 30 is going to be the perfect answer down here in the table.